Okay, welcome to the continuation of the PCEngine-Turbografx programming tutorial. It took me a while to get some things together for various reasons. Well, I'll get into that a little bit later. But yeah, this winter I've been quite busy with not a lot of free time at home with a quiet household. So now that I finally have it, for today anyway, I'll get a video going. Let's see. First, I guess I will talk about how to get some of the needed programs downloaded on your computer and up and running. And I'm sorry if this is a little bit too Windows-centric. There might be other options for your computer. I know that there are assemblers that have source code, which probably means you can compile them for other operating systems. I'm running on a Windows PC, and that's what I'll show. But as far as PCEngine emulators and text editors go, they're on every system under the sun, so you can use your favorite one for that. Okay, well, first I'll get started with some download links. Mednafen is a pretty good multi-system emulator, and here's the homepage, mednafen.fobby.net. That's F-O-B-B-Y. I guess I should spell the whole thing, but you can read it anyway. Mednafen, it's in giant logo right here, .fobby.net. And it supports Atari Lynx, Neo Geo Pocket, WonderSwan, Game Boy, NES, Super NES, Virtual Boy, PCEngine, Turbografx, PCFX, and then various Sega systems, Sony PlayStation. It is basically command line only. It doesn't have its own GUI. It has a lot of keyboard shortcuts and configuration using the keyboard. So, it's not exactly GUI and modern operating system friendly. That sucks. But, well, as far as having many features and, pretty good debugger, it is great. So, you should download it. Maybe get the latest version or an earlier version. I'll show you what to get done. Actually, I have one downloaded already, but I'll delete that and start again. Well, make a new folder in your emulators directory. 0.9.39.2. That's the newest one. That's on their homepage anyway. I'll download the Win64 version once again. I have an older version, which I use, and it's fine. This one apparently has Sega Saturn, improved Sega Saturn emulation, so you can use that if you want. I don't think it really matters for PCEngine, really. I always just worry about speed and latency on my kind of slow laptop PC. Newer versions tend to start chugging worse and worse, and I don't know why. But okay, you downloaded this and open up the zip file, copy it to the new folder which you just made. Okay, Mednafen is downloaded. All right, and so if you drag a game ROM over Mednafen, it'll start running, I suppose. So drag it over, say yes. And it'll run in a window right here. It's kind of upscaled and blurred, and I'm sure there are options to turn that off. You've got to find them yourself, however. If you do Alt-D, you can turn on the debugger, and yeah, that font is incredibly tiny. You can change that, however. So let's stop this. Let's go back to Mednafen. There we go. When you start up Mednafen once, it'll create a bunch of directories. So you should run it once just by dragging a ROM over it. And then it creates a config file here. And this config file is automatically generated. You can edit this, but then if you run Mednafen again and change some options, it'll overwrite it again, so it's a bit annoying. But okay, take your favorite text editor. I've got context running here. Let's stop that. Okay, and drag the config file over. So this is the automatically generated config file. Edit it at your own risk. If you do a search for PCE, then that'll bring up all the options for the PC Engine emulator section. Volume mixing, where the CD BIOS path is, or what's the path of CD BIOS, volume. Here, debugger font. In an older version of Mednafen, it says, debugger font size, small, medium, large, and here it actually has some numbers. Now, what are the options you have? I don't know. So I had to search for that. Here is PCFX documentation. Well, probably PC Engine is the same thing. But anyway, this should probably be the same thing. PCE.debugger disk font size. Here are some values: 5x7, 6x9, 6x12, 6x13, or 9x18, and the default is 5x7. This is the smallest. Let's try changing that to 6x12. Just to get some sane and normal viewable size going here. All right, and you can change other options. Disable the backup RAM. Force mono. No, you don't want to do that. If you're going to do Supergraphics programming, you might want to turn this option on, force XDX to 1, because otherwise Mednafen kind of only will run the commercially released Supergraphics games as Supergraphics ROMs. You can change overscan area, which is kind of important later, and then there's gamepad mapping options. Yeah, it's a bit of a hassle. Right after the gamepad, unfortunately, is mouse and then the Tsushin keyboard options, a whole bunch of them. This could be organized a bit better. What can you say? No sprite limit, OpenGL pixel shader, scan lines, no. You can change the overscan, so first and last rendered scan line. This can be important if you want to actually see what your modern TV would show. I would recommend changing that to 239 and then this down to like 1, quite honestly. Most TVs can, a lot of TVs do cut off the borders in overscan, but if you set the PC Engine to 240 line mode, you actually want to see what you've done. So unfortunately, this limitation in Mednafen it starts up a default by cutting off some top and bottom borders. So here we go, blur and so on. Bilinear interpolation, I'm turning that off. I don't want it. And here's scaling sizes and stuff. So save that, and it should look a little different. Copy that over. Yeah, so there, interpolation and blurring are out. It's chugging a little bit. Well, the debugger window is not much better, but it is larger. You can set it to a larger size if you want. Okay. And I guess the final thing you want to do is to have it automatically load up Mednafen when you run a ROM. I'm not going to do it with this version, but yeah, close that, reload from disk. No. So double click on that in Windows and you'll come up with the familiar program thing. You'll find your version of Mednafen that you want to run it on, and if you're lucky you can select that and it'll load up Mednafen automatically whenever you do that. Oops. There we go. I already have that mapped, so when I double click on a PCE ROM, it'll load Medifin in kind of, well, this is my setting, smaller screen. There we go. Okay, so that's how you download and configure Medifin a little bit, just to make it look fine. There are lots of options in both in the config file and real time. So you really have to delve into the instruction pages for Medifin. For example, if you do Alt and Shift and 1, this is where you can change the gamepad settings. Geez, there's a lot of them. So select, run, 2 or 6 button mode, gamepad. There. You can configure a lot. So everything is, button combination based, using combination of Control, Shift, and numbers and so on. But at least this thing works with the joypad as well, and it has rapid fire. 2 and 6 button modes as well. Alright, so that's Medifin running. Again, as I said, in addition to an emulator, you'll need your text editor, so I'm using Context. I quite like it. Let's see. I'll run this. Okay. Context has a highlighter. Has lots of highlighters, 6502, C, Z80 assembler, etc. that you can download, and this will basically run. It'll highlight the instructions and color code the opcodes and the values, the operands, I guess you call it, and comments and so on. So it's a bit more readable. Comments become a little bit paler green, as you can see there. So you can download that with Context, but a lot of other text editors like Notepad Plus or there's a whole bunch of them, and they have highlighters for assembly and other computer languages. So that's what I recommend. But I won't give you links to that. You use whatever you like. Okay, so now we get to the main event, getting the programming software for the PCEngine-Turbografx. And the main reason that this video has taken so long to make is that I found out over several weeks that the software that compile and assemble the PCEngine programs is very much in flux. The software world is kind of split up a little bit. How do I put this simply? Well, originally there were a couple assemblers for the PCEngine-Turbografx, and that was it. And that was usually just called Magic Kit. Magic Kit would assemble NES, Nintendo, 6502 code, as well as PC Engine code. And then over time, Who's C, a very small C language compiler, was created and developed for the PC Engine as well. And that's great. It allowed a semi-high level language to be used to program games. Who's C would take your C program or your C language files and compile those into assembly files, and then they would use a modified version, I guess, of Magic Kit, PCE assembly, to then assemble that object code into a runnable PCE-ROM. So basically, maybe Magic Kit and the assemblers were around first, and then the C compiler used the power of the assemblers. It leveraged Magic Kit. And as both of those individually got modernized or optimized, they kind of became incompatible with each other. So even though whoc comes with a C compiler as well as an assembler toolchain, you can't use the assembler that comes with whoc and use the same libraries that came with MagicKit. Over time, they became incompatible. So what the hell am I going to do then if I want to teach assembly programming? Which one do I use? Do I use the most modern thing that's in whoc? Or do I use some really old DOS-only programs that are in MagicKit? I was kind of at a loss there, and so I'm explaining why this took some time. So anyway, I'll show you, I'll point out some links to whoc and its various revisions, and then I'll get down to the assembly, which assembly program to use. This is I guess the more recent and most common whoc version at zeograd.com, www.zeograd.com, whoc version 3.2.1 Denki release. It was modified and upgraded by a person called Denki, I suppose. And I think a lot of modern whoc revisions are based on this. So you can, if you want to go the C programming route, by all means go ahead, download it here, learn how to use it, stop this video, and have fun with C. But the purpose of these tutorials is not to teach C programming, but actually assembly. Some very good games can be made in whoc or in C on the PC Engine. It's just fast enough to get some slightly good performance out of action games using C. Now, however, when I play games that are programmed in whoc, I can see that they are a little bit slow. They judder a bit. They stutter a tiny bit. The frame rate is not all there. It's hard to optimize it perfectly. If you want to optimize something programmed in whoc, you wait for a more modern version to come out where people are actually optimizing whoc to create more efficient assembly code, or B, you find what parts of your game are not optimized and then rewrite those in assembly. So option B, it means you have to use assembly anyway. I want to actually hit the bare metal and get it more like it was in the olden days, where you would have to use assembly wizardry to get some amazing stuff going, and that's more satisfying to me anyway. Back when I was in college, I learned C and I also learned assembly, and C never satisfied me. Assembly wowed me, and so that's kind of what I loved ever since then. So anyway, here is whoc. Here's a link to it. This is a good starting point. I don't know how to run it or compile programs for this. This is just a pointer to it. However, from this, people have been enhancing this version of whoc. So if you go to GitHub, there is this enhanced version of the development system whoc. It's at github.com/uli/huc, and that's an ULI build of whoc, and this shows what is happening and what's being enhanced. And actually, I believe Artemio has made his own version of whoc based on this, which goes even further. So it has some pretty good libraries. However, if you compile something in whoc, it creates many K of helper libraries and some kind of unneeded banks, many banks of unnecessary software layers, and that's really what I don't like. Even the latest version of MagicKit, or the MagicKit that's included in whoc, splits a lot of these assembly files into many different banks, and that's quite a headache too. The oldest versions of MagicKit put everything into only one 8K bank, and that's kind of where I want to go in these videos, get down to just starting with one 8K bank, adding your own libraries and keeping it simple and efficient. And anyway, if you want to learn how to program on the PC Engine, I recommend starting out at the most basic level anyway and learning what do you have to do, how do you start up the system, how do you initialize it. And actually it's quite simple. It's a lot simpler than something like the Super Nintendo. Pause this video right now and go and look at the initialization routine for homebrew Super Nintendo games. You can probably find it online. It is unbelievably complex. So many registers to write to on the Super Nintendo. The PC Engine is a bit simpler, and that's kind of the benefit of it. You get great graphics with just a little bit more complexity than the NES, and a lot more flexibility than the NES as well. So that's pretty much why I love programming on the PC Engine. Huge flexibility, great power, and still quite simple code. So that's where I'll leave this. GitHub is where you can get this more enhanced version of Husi. And here we go back in time. Here's MagicKit. www.magicengine.com/mkit/download@html. You can see here there's MagicKit 2.51 and Husi 1.4.2, and they're DOS only and Linux only. So this is quite old and crusty. I could start teaching using the tutorials from here, but then you can't actually run it on a modern Windows system. So what I recommend you do is, well, download MagicKit. Download it, open it up. It comes with the binaries, and these are old DOS binaries. We won't be needing those, I think. It comes with a folder for NES and PC demos, which are empty right now. Empty. See, empty. It comes with some good documentation right here. So this is what you can actually read to find out just about the CPU, instructions, about the PSG, the sound, sprites. So the good thing about this really old crusty MagicKit release is that it has good documentation. A sprites tutorial, some needed and important byte layouts for sprite definitions. You will be referring to these many times, I think. So this is quite useful to download. Of course, it has an NES section as well. If you want to do NES programming, you can also do that too. One really useful thing is a whole bunch of include files for the PC Engine. And although there are these in Husi and the more recent version of the assembler, they have been added to and enhanced to make it kind of a Frankenstein version of these original files. So what I'm going to do is I'm going to start with absolutely nothing, but it's important to build up your own libraries to make them kind of look like this, a standard include library, something like this. At the very start you'll have macros, equates, and a startup library. And so we will be building our own libraries that will probably start looking like this, and you can borrow code from here if you want. So this is pretty useful, even though it's getting old. All right. All right, so I'll just copy these here. Okay, so that's MagicKit, but let's see. These binaries, I don't think we need them. Delete them, just to remind yourself that this won't work. I'll close that up. Okay, so you downloaded MagicKit, and there are some actual ASM demos for the PC Engine, and so you can refer to those as well for ideas and some tips. So open those up. Copy those over. Oops. Well, it has a directory layout all weird. Demos. What did I do? Well, not a problem. Yes! Okay, so that should work fine. Here's one that I saw really early, Starwave. You might have seen this too if you were into PCEngine emulation in the mid-90s or late 90s. So this actually has the assembly source of this demo, which is, pretty awesome. You can study from this just to make your own demos, really. Yeah, so that's Magic Kit. Okay, we've downloaded that. And as well as downloading Magic Kit, here's a site that I recommend. It's basically a wiki, not quite complete, but it has an overview of how to set up, or at least use Who-C. How to set it up, how to use it, some tips. So again, if you're going to go into C, you can use this. I recommend it. There's also PCEAS assembler. Okay, PCEAS setup. Oh, there's no page. Okay, so here's a weak point of this page. Really, it ignores assembly. A lot of people are going to C. They don't want to go into assembly, or at least they're doing it all by themselves. So that's kind of the problem. This transitional, or what do you call it, balkanized situation we have in the PCEngine programming world now. Some people do assembly, but they don't really make any tutorials or any wikis like this. At the very least, it has a instruction set, reference guide, as well as the memory map and other internal chips and so on for the PCEngine. So this is a good reference to look at. It's archaicpixels.com, and there's a wiki built in here. All right. So I might refer to this again. Finally, so what to do? How do we get a more modern assembler going? Well, let's start by going to Tomatheus's webpage. It's pcedev.wordpress.com, and here I have it on the downloads and links section. Tomatheus, also known as Bonknuts, has done a lot of work with assembly programming and reverse engineering, hacking, etc. And he has a good bunch of resources here. PCEngine crib sheet that I pointed to before is available here. There's a sprite size diagram, I'll show that later. PCE mouse support, mouse we don't need. He made a new version of the PCEAS assembler, and that's what we need. We'll use that. It's a bit enhanced, it's quite good. It has a tutorial, or not a tutorial, it has a list of enhancements. So download that, open her up. The Magic Kit. It's my downloaded version. Okay. So this is a PCEngine file here. It runs, well, there are two, test2.pce. This runs, but you can't see anything. It just demonstrates some of the extra features that he's added to the newer version of PCEAS. But this is it right here. What I recommend you do is you just copy this to your Windows System32 directory. You'll be using it more often, so you don't need the exe file in another location or inside each programming project's folder itself. You can just put it in its own directory. That's what I did with PCEAS as well. So I'll copy that here. Bye bye System32. Okay. And so now if you want to assemble your project like test2.asm, you just have to run go.bat. However, that should run it as well. Okay, no problems, no worries here for now. You run PCEAS, have it in raw mode so it has no headers. It has a more verbose level of debugging output. And then, well, don't need that pause, maybe. But I'll run it, see if it works. Nope. There we go. So, well, this warning, you don't need to worry about this warning. This was intentional. Tomatheus has upgraded PCAS, the original one in Magic Kit, because it had a few limitations. The original one couldn't cross 8K bank boundaries with code, which is kind of dumb. Everything was limited into 8K of ROM. And crazily enough, the NES assembler also had that 8K boundary limitation, even though NES ROMs are usually 16K or larger. So that's kind of nuts. So this is just a demonstration of the enhancements, that you can have an opcode start at 5FFF hex, and then it'll go into 6000 hex and not wrap around or fail to compile or fail to assemble. So this is pretty good. Okay, so we have the assembler set up, and the next step is, I guess, we will just get started, initialize the PC Engine and TurboGrafx system. Okay, one other important piece of software that I should mention is graphics editing software. I mean, how do you get your graphics into your PC Engine program or your demo? Well, the PC Engine uses an indexed tile-based graphics format, so of course you need to do most of your work in an indexed graphics editor. Now, what does indexed mean? Well, it's not the same as like Photoshop, which is 24-bit true color photo editor. Indexed means it uses palettes, which are limited from either 2 colors or 16 colors to the maximum of usually 256 colors. And there is a master palette in the system, in this case the PC Engine, that all the bit planes point to. So if you change some color in the palette, every tile or graphic element that points to that palette entry will change instantly on screen as you change that master palette. So it's quite a different beast from editing some photograph in Photoshop or whatever. So that's something you need to watch out for. You need to think in tile-based and indexed color modes, not the whole 24-bit graphics that you get on modern computers and modern game systems. Well, I don't use Photoshop, and for quite a good reason, a very important reason, and I'm going to show you that right now. Here I've simulated some pictures that Photoshop would create or save. I just made a very simple picture with 8 shades of gray going from black to white, and some text dark to light. And this one I saved as a 16 color, 4 bits per pixel, GIF file. And if you look at the palette, you can see that black is index 0, and that's what I want in this case. If I have sprites on screen but they're behind the background, this index 0 will be transparent, so sprites will show up here. But if the sprites pass to any other part of the graphic, like this gray, those sprites will be behind and hidden by these other colors. So index 0 is always transparent on the PC Engine and other game systems, many other game systems. And so you really want to have fine control over which color in your background is transparent, because you can only have one of them. And in this case I chose it to be black. White is the next color, and then there's some in between. And if you save as a GIF in Photoshop, you get this kind of control. However, the identical image, the same image, I saved it as a PCX, which is what Magic Kit needs. So it's the same picture, the same indexed graphic, but Photoshop has saved it as 8 bits per pixel, and that's 256 colors. So it's kind of upgraded it to using all the colors in the indexed graphics. However, if you look at the palette, look at all this. There are 240 colors that are all black, and this palette that you need is actually reversed, it's backwards. So Photoshop, if you save it, your index graphics as PCX, it'll reverse the palettes completely. Black is now the last color in the index, and then white, and then this minty green is color 0, or the transparent color. All the 0, 16, 32, all of these colors are all transparent on the PC Engine. So now this minty green will be transparent. Sprites, if you put a sprite behind this graphic, it won't show up anywhere except in some of these minty green transparent locations, and that's not what you want. So frankly, Photoshop screws up your graphics if you save as an index color as a PCX. So you'll need to use a different program for conversion to convert from a GIF to PCX. You should use something else. That's kind of what Photoshop does, and that's one reason why I don't really use Photoshop. You should use something else. GIMP, some Graphics 2, that's a very popular paint program on the PC and other systems. Graphics 2, by the way, is GRAFX and the number 2, so you should search for it that way. And that's kind of a Windows or modern platform copy of Deluxe Paint on the Amiga. But yeah, watch out for Photoshop. It'll if you save as a PCX, which is what Magic Kit needs, it'll royally screw up the palette. Yeah, as I said, it reverses the colors. Another thing, so not only will sprites be hidden behind everything except for the minty green, if you load this graphic in and import it in Magic Kit and import the palette as well, you'll just have all black on screen. And because the first first 16 color entries will be loaded in, but it's all black, and you will think that you've programmed something wrong in your program, and it's not your fault. It's Photoshop which shoved it way to the back of the last palette in the picture. Yeah, so that's quite disappointing. I wonder if they've fixed that in more modern versions, but the last time I used Photoshop on a computer, it screwed up like that, so I don't really use it for PC Engine graphics editing at all. Yeah, and not only were the color was this shoved way back, the colors were reversed. So if you load the indexes, this is now color 254 and 255. That's not what you want. You'll want finer control over your graphics, which means a different program. All right, I'll show you what I use when I'm doing painting or doing graphics on the PC Engine. You might not want to do it this way, but my teenage years were spent playing around with paint programs on the Amiga, and that's near and dear to my heart too. So for me, nothing beats the flexibility and power of making bitmap graphics in Deluxe Paint and other programs on the Amiga. So that's often what I do if I want to play around with graphics, change the palette quickly, not fool around with 24-bit graphics modes. Hopefully this shouldn't break up, but here's a Windows Amiga emulator, WinUAE. And there it loads quickly enough. So yeah, I recommend you get, if you want to try it this way, I recommend getting an Amiga emulator and finding a Workbench 3.1 ROM and some hard drive image like this, and mapping one of your Windows or other operating system directories to a virtual disk on the Amiga like this, so you can go directly and save graphics to the other side of your system. A few of the programs that are really useful here are Personal Paint, ppaint, because that saves IFF, saves and loads Amiga IFF, as well as GIF and PCX files directly. Deluxe Paint only saves IFF, but it has great gradient, shading, animation, and palette editing capabilities, greater than any of the other programs here. Brilliance is quite good, and I'll show why in a minute. And Art Pro, let's take a look at Art Pro here. It's pretty useful because you can load any graphics file format basically, and then save it, convert it to some other format like GIF or PCX is the main one we want here. See, rendered, not 24-bit, rendered, maybe VGA is okay. Rendered VGA is fine. So you can create your graphics in anything on the Amiga, and then you can use ArtPro to convert it to PCX. That's one way to do it. Okay, let's start up Brilliance. Now, Brilliance is of course great for animation and art and doing gradients and transparencies in index color modes, so I won't get into that. But I'll show you some of the features that Brilliance has over the other programs. If you go to the screen settings, of course you can change your screen size, and the Amiga has adjustable resolution. And you can of course change the paletted colors. The PC Engine of course allows up to 256, like that. Background colors, minus the transparent ones in each 16 color index. And it allows 256 sprite colors as well. So you can adjust that. Most indexed graphics programs or paint programs let you change the color definitions from 2 colors, 4, 8, and 16. And the Amiga has a few in between, like 32 and 64 colors. And you can, of course, paint with any color and fill that in. And you can edit the palette with any value from 0 up to 255. That's the color depth of 24-bit graphics. The PC Engine, however, uses 9-bit color depth. So instead of 16 million, which is the PC Engine, which is the Amiga's AGA and modern operating systems color depths, you can change this in Brilliance down to 512. And now you can paint directly in all the colors that are available only on the PC Engine, and not any more that aren't available on the PC Engine. So as you can see here, this color now goes from 0 up to 7 for each of the color channels. And you can, of course, change this for other, systems that you might be working on. Who knows? 64 is for the Sega Master System. 4096 for the old ECS or OCS Amigas. 32,000 colors for the Super Nintendo. And so on. Okay, so I'll load a picture in that I prepared earlier to show some of the limitations of the PC Engine. Alright, it's a picture that I prepared earlier. Okay, this was a nice, pretty 24-bit image that I converted down to 256 colors, but still using a 24-bit color space. And if you hoped just to copy your photos and limit them down to the PC Engine's limitations, you might be in for a little bit of a surprise. You might be in for a bit of a shock. As you can see, we're in 24-bit color space. And here are all the colors in the palette. It's a lot of blues, silvers, grays, and so on. Now if we change this bit depth down to something the PC Engine needs, namely 512 colors, yeah, that's what it looks like. You'll see a lot of banding and color distortion, and that's not what you want. Well, you can try editing and just bringing in photorealistic images into the PC Engine's color space yourself, but I don't recommend it so much unless you're prepared to do a lot of tweaking to get something looking just right. I really recommend, on a slightly old school system like the PC Engine, you should draw your own graphics in a paint program starting in the 24-bit color space, or scan your hand-drawn graphics and then colorize them again in a paint program like this. Because as you can see, it remaps a lot of these subtle dark tones to just black, and it remaps similar looking grays all to the same shade of gray. So as the PC Engine only has 3 bits per color channel, which is only 7 levels of red and 7 of green, 7 of blue, that means only 8 shades of gray basically. So here's one I made before. This is still in the PC Engine's bit depth, but if you start with more vibrant colors, you will feel the limitations a lot less than if you start with the muted shades. And that's kind of what pixel art is. Pixel art uses a lot of vibrant colors, or not exactly grayscale because there's only 8 tones of it, but you could go from black to dark blue to silvery blue to gray for the dark tones, the cool tones, and then go from this medium gray to, for example, red or orange, then up to yellow, then finally to white. So instead of going directly from black to white, you can travel through this slightly limited color space to get more. You get a tiny bit more garish, or a little bit harder to wrangle colors, but that's how you can get more colors on screen and not have this horrible banding. This triangle I made using almost all of the PC Engine's background colors, so it's using 240 colors, and it's quite nicely shaded and colorful, and you can pick from a lot of tones here if you like working with rainbows. But anyway, this shows you some of the limitations of the color space of the PC Engine. I'll zoom in a bit. Yeah, so I just picked these. Well, I just picked this as a representation of the PC Engine palette, but as you can see, there is a hard limitation. From red to orange, from red to yellow, there's only 8 steps. And then again, from yellow to green, there's only 8 steps. So that is a tiny bit limiting. From black to red, full red, there's only 8 steps. You'll have to keep that in mind as you're drawing your graphics. And that's why these bitmap image programs or bitmap paint programs help you. In Photoshop, you won't be able to see the limitation until the final step or the final stage, where making corrections might be too late. So, well, that's where I'll stop here. That's where I'll stop this video. I think I've drilled it home enough. It's fun to paint in paint programs, design your own gradients, adjust and tweak palettes, not the graphics themselves as if it were a photo. That's kind of the mindset you'll need to be in when doing this old school programming. Anyway, I hope you enjoyed this video.